Okay. Yes. So very good afternoon, students. So the continuation of electric potential and capacitance. So the next topic in electric potential and capacitance, our topic is capacitors. So what is mean by capacitor? Capacitor. What is mean by capacitor? It is the one of the electrical device. A capacitor is an electrical device. It is used to store the charge. It is used to store the charge or used to store the energy. Some of the electrical appliances so may not run initially. Some of the electrical devices some of the electrical devices may not run properly with a low voltage. So for like electric motor, fan, etc. So we are using condenser or capacitor. ये already energy store करके रखता जब हो ना तब देते energy. Such a device is called capacitor. The capacitance of a capacitor formula C is equal to Q upon V. The capacitance of a capacitor C is equal to Q upon V. Capacitance of a capacitor. So but capacitance does not depends on charge, does not depends on voltage. So C is equal to Q upon V is the capacitance formula. Q is equal to C into V or V is equal to Q upon C. It is the basic formula for capacitance. So there are different types of capacitors are there. Parallel plate capacitor, spherical capacitor and cylindrical capacitor. The main important formula capacitor में so capacitor the parallel plate capacitor C is equal to epsilon naught A by D. So when parallel plate capacitor so this is the one capacitor इसके पास charge plus q इसके पास charge minus q so this is the positive charge it is the negative charge separated by a distance d separated by a distance d so area of each plate is a area of each plate is a so between them there is a air is a medium air is a medium the capacitance of a parallel plate capacitor epsilon naught A by D so in this air parallel plate capacitor if it is plus q this is minus q so if you are placing one medium of dielectric constant k so of dielectric constant k the capacitance of a parallel plate capacitor k times of epsilon naught A upon D k times of epsilon naught A upon D. So if dielectric medium completely filled between the two plates of capacitor k times of epsilon naught A by D. So if dielectric medium completely is not filled, if it is partially filled, dielectric medium of dielectric constant k so and thickness T so this is capacitor plus q minus q so separation between them is D so dielectric constant is not filled completely then the capacitance of the capacitor C is equal to epsilon naught A by D minus T plus T by K D minus T plus T by K so this is the formula for so capacitance of a parallel plate capacitor capacitance of a parallel plate capacitor. So now the capacitance of a spherical capacitor. The capacitance of a spherical capacitor, how it is? The capacitance of a spherical capacitor. So if it is spherical capacitor, this is one plate of charge q another plate separated by of charge this is connected to earth इसका radius a मान लिया इसका radius b है तो the capacitance of this capacitor formula c is equal to 4 pi epsilon naught into so a b upon b minus a b upon b minus a this is the capacitance of a spherical capacitor so this is the capacitance let us go for combination of capacitors this one this is a parallel plate capacitor just now I have given so between the what is the energy stored in a capacitor the energy stored in a capacitor half cv square now the q square by 2c otherwise qv by 2 the energy stored in a capacitor formula q square by 2c now the half cv square now the qv by 2. What is the energy density? Energy per unit volume. Energy density means energy per unit volume. The energy per unit volume of the capacitor formula, half epsilon naught into E square, where E is electric field, half epsilon naught into E square. And the force between the two parallel plate capacitors, force between them formula is what? Half CV square by D, energy per unit distance, CV square by 2D, or half epsilon naught into E square into A, half epsilon naught into E square into A. So this is called force between the two plates of the parallel plate capacitor. So just energy per distance, the separation between the plates, are half epsilon naught A into E square. That is the force between the two plates of parallel plate capacitors. Shall we go for? So capacitors, combination of capacitors. There are two types of combination of capacitors. One is a series combination, another one is a parallel combination. In series combination, effective capacitance do you want? We have to add reciprocally. 1 by C effective is equal to 1 by C1 plus 1 by C2. In parallel combination, the effective capacitance is C parallel is equal to C1 plus C2. This is in parallel combination. This is in series combination. So this is the energy stored in series combination. दोनों ऐड करना. Energy stored in parallel combination. Parallel combination में C1 plus C2. Series combination में 1 by C1 plus 1 by C2. 1 by C1 plus C2. So let us go for next topic. Yes. Right. So this is not required. So redistribution of charges. How redistributed? Nothing but common potential. What is the common potential? So one plate, this is the one plate, this is another plate capacitor. So do you want to find out common potential? So this concept we don't want to require. So let us go for, this is positive plate connected to a positive plate of the another capacitor, negative plate connected to a negative plate of the another capacitor. The common potential formula, C1 V1 plus C2 V2 upon C1 plus C2. The common potential formula, C1 V1 plus C2 V2 upon C1 plus C2. If a positive plate connected to a negative plate connected to a positive plate hai to, so you will get C1 V1 minus C2 V2 upon C1 plus C2. C1 V1 minus C2 V2 upon C1 plus C2. So this is the common potential. And what is the loss in energy in this case? Loss in energy, delta U is equal to half C1 C2 upon C1 plus C2 into V1 minus V2 whole square. So what is the loss in energy? So one capacitor loses charge, it will give to another capacitor. The loss in energy formula, delta U is equal to half C1 C2 upon C1 plus C2 into V1 minus V2 whole square. So this is the energy stored in the capacitor, and common potential of the capacitor, and energy loss in the capacitor. Energy loss in the capacitor. Right. So let us go for, this is already given, just parallel plate spherical capacitor just now already given. Spherical capacitor formula, C is equal to Q by V, 4 pi epsilon naught into AB upon B minus A, just now I given. Cylindrical capacitor formula, capacitance C is equal to 2 pi epsilon naught into L upon log B by A, so base E, log B by A base E, or natural logarithm. Natural logarithm, it is the capacitance of a which one? Cylindrical capacitor. Cylindrical capacitor. So let us go for next one. So this is not required, this one. So this is a polarization, you know already in the last class already mentioned. Let us go for solve it some numericals. Solving some numericals. Dielectric, just now I given formula, epsilon naught A by D minus T plus T by K, epsilon naught into A by D minus T plus T by K. So it is just now I given. So you come to know. Shall we go for solving some numericals on capacitors? Let us go for two capacitors of capacitances 8 microfarad and 20 microfarad are connected in series with battery. The voltage across 8 microfarad capacitor is 5 volts. then the total battery voltage is how much? So two capacitors, this is one capacitor, are connected in series. This is 8 microfarad, this is how much? 20 microfarad, 20 microfarad. So both are connected. A voltage across 8 microfarad is 5 volts. Across 8 connected to a battery is mentioned. Across 8 microfarad voltage is 5 volts. What is the total battery voltage is how much? The voltage across 8 microfarad given 5 volts. So total battery voltage kitna hai? Let us assume that V. We want to find out total battery voltage. How much we have to find out? So how to find out total battery voltage? Shall we go for this one? So here same charge will be flows. In series combination, charge remains same on both capacitors. In parallel combination, potential difference same on both plates of capacitor. So but in series combination, charge will remain same. Charge will remain same means first we can find out charge on this capacitor. First capacitor Q1 is equal to C1 into V1. C1 into V1, 8 5 is 40. 40 into 10 power minus 6 or 40 microcoulombs charge. इसमें जो चार्ज है सेकंड कैपेसिटर में भी चार्ज सेम है. Q2 also is equal to 40 microcoulombs charge. If we come to know charge, we can find out potential. Potential V2 is equal to Q by C. So Q2 by C2. Q2 is 40, C2 is 20. It should be 2. So 2 volts. What is the potential on second capacitor? 2 volts. The potential on second capacitor is 2 volts. So when potential second capacitor 2 volts, it is series combination 5 plus 2. So the main supply voltage 7 volts. The main supply voltage is 7. So dear students, please check it. इसमें से series combination का पूरा clarity picture मिल गया. So two capacitors are connected in series combination. It is given by 2023. So CUET examination 2023 question है ये. Right. So 8 microfarad, 20 microfarad, 8 microfarad, 20 microfarad are connected in series combination. So what he is asking, find the potential of the battery. Battery drawn voltage drawn from the battery. Right. Direct formula. So see, Q is same in series combination. Potential is same in parallel combination. Right students. So let us go for next one please. The capacity of the earth is approximately how much? What is the capacity of the earth is approximately? Capacitance of the spherical capacitor formula, spherical conductor 4 pi epsilon naught r. So earth is a spherical conductor. Earth is a spherical conductor. The capacitance of the spherical conductor formula 4 pi epsilon naught times of r. 4 pi epsilon naught times of r. So now this one 4 pi epsilon naught value 1 by 9 into 10 to the power of 9. Radius of the earth 6400 into 10 power 3 kilometers. 6400 into 10 power 3 kilometers. If we solve it this one, so 64, so 3 cancel, 5 cancel, 64 by 9 into 10 power minus 4. 64 you will get 0.711. Otherwise you do one thing, 9 7 ja 63, 7.11, 7.11 into 10 power minus 4. Shall we go for 711 into 10 power minus 6? 711 microfarad. 711 microfarad. It is also given by 2023 CUET examination. So it is also given 2023 CUET examination question. So this is the electrical capacity of the earth is approximately. So earth is a spherical conductor. The capacitance of a spherical conductor formula. So I will show you derivation. C is equal to Q by V. So spherical conductor potential. What is the potential of radius of the earth is R? Potential formula 1 by 4 pi epsilon naught into Q by R. Substitute here. So 1 upon 4 pi epsilon naught into Q upon R. Q get cancelled. It should be 4 pi epsilon naught times of R. 4 pi epsilon naught times of R. Right. So let us go for next question. So a question to already करे मैं in the last chapter only I did here. So what is the electric potential difference and potential का question? E equal to minus dV by dr. Even though you can check it once again. E is equal to क्या दिया minus dV by dr. So potential difference is asking what is the potential difference between point A and C, not I. So A and A, B, C, these all the questions last 2-3 years में जो question दिए CUET में वही questions मैं explain कर रहा हूँ. So please go through once. dV dV is equal to minus of E into dr. So what is the electric field here? The electric field has given 2 into 10 power 3. 2 into 10 power 3. So distance A distance because of C का B का potential same है. A distance 4 centimeter हो जाता. This is 4 into 10 power minus 2. It should be 80 volts. Potential difference is 80 volts. So 80 indicates along the direction of the electric field potential decreases. Along the direction of the electric field potential decreases. Note down the point. Along the direction of the electric field potential decreases. So that is the indication of negative sign. Along the direction of the electric field potential decreases. Right? Let us go for one more question. So linear charge density, electric dipole moment, polarization vector, electric flux. Matching question diya. So he has given matching question. So unit, just unit. You know, direct simple one. First you go for electric dipole moment. So electric dipole moment बात करें तो electric dipole moment Q into 2A. Electric dipole moment Q into 2A. So charge is in coulomb, distance is in meter. Coulomb meter is the unit. Coulomb meter. So obviously B का option 4 होता. B का option 4 हुआ तो, am I right? Coulomb meter. So you have only one option. Sorry. B का 4. B का 4 you have two options. Option 1 नहीं होता, option 2 नहीं होता, maybe option 3 or option 4. Option 4. So shall we go for electric flux or linear charge density? Linear charge density lambda बात करें तो charge per unit length. Charge per unit length. So coulomb per meter. Coulomb per meter किसका होता? Linear charge density A2. So A2 again it is not possible. A2 B4 दोनों से. Shall we go for D? Electric flux. Flux का unit क्या है? Flux E into A. E into A. So flux का unit generally Weber. Flux का unit क्या है? Weber. So maybe here get 1 or 3. What you will get? Flux का unit. Coulomb per meter square ले सकते. Flux, electric flux. Do you want in terms of charge? Flux pi is equal to Q by epsilon naught. Q by epsilon naught. So Q is coulomb upon epsilon naught का unit क्या है? Epsilon naught का unit. So epsilon naught F is equal to 1 by 4 pi epsilon naught into Q square by R square. Epsilon naught का coulomb square. Epsilon naught coulomb square per Newton meter square. Newton meter square. एक coulomb cancel. Newton meter square upon coulomb square. That is किसका unit है? Flux. So D is belongs to 1. D is belongs to 1. Now again polarization vector. The polarization vector numerically equal to, so surface charge density. The polarization vector is numerically equal to surface charge density. So that region polarization vector P is equal to surface charge density, charge per unit area. So it should be written as coulomb per meter square. Coulomb upon meter square. Coulomb upon meter square. So that region. So this is a polarization vector is belongs to 3. So this is, it is possible only option 4 is correct. Option 4 is correct. So let us go for next question please. ये तो आसान क्वेश्चन है. So very clearly I mentioned E inversely proportional to R square. The graph you will get. So E inversely proportional to R square. This is E versus R square. E inversely proportional to R square. This is V inversely proportional to R. ये slowly change होता, ये suddenly change होता, compare because of square. E inversely proportional to R square. Check it here. फर्स्ट केस ई इन्वर्सली प्रपोज ए तो 100% पॉसिबल नहीं है, 100% पॉसिबल नहीं, ये ऊपर है ए भी पॉसिबल नहीं है, द ओनली वन ऑप्शन पॉसिबल ई इन्वर्सली प्रोपोर्शनल टू आर स्क्वायर। ये डायरेक्टली एनसीईआरटी का एनसीईआरटी टेक्स्ट बुक में डायरेक्ट ग्राफ दिया, सो 2023 में डायरेक्ट ग्राफ दिया। लेट अस गो फॉर नेक्स्ट क्वेश्चन प्लीज। Three charges Q plus Q are placed at the vertices of equilateral triangle of side L as shown in the figure. If the net electrostatic energy of the system is 0, then E is equal to how much? Then Q is equal to how much? Three charges plus Q are placed at vertices of equilateral triangle side L as shown in the figure. If the net electrostatic energy of the system 0, the Q is equal to, I hope this one, not this one, this is Q is equal to, what is the value of capital Q? What is the value of capital Q he is asking. So what is the value of capital Q? So how to find out this one capital Q value? How to find out? So let us go for here. How to find out capital Q value? System is in equilibrium, net potential energy of the system is 0. Net potential energy 0 means net potential energy 0. So ये दोनों को बीच में K Q into Q square upon L square upon L. What is the potential energy? K Q1 Q2 upon L. K Q1 Q2 upon R. Between two charges, what is the potential energy formula? Q1 Q2 two charges है तो potential energy formula K Q1 Q2 upon R. Force formula K Q1 Q2 upon R square. Am I right? One more thing I want to show to you. So there is only one charge is there. So at this point P at a distance R, what is the electric field? K Q by R square. What is the potential? K Q upon R is the potential. So problem में मैं इस formulas बता रहा हूँ, please check it. Two charges है तो potential energy का formula K Q1 Q2 by R, force का formula K Q1 Q2 by R square. So एक ही charge है तो K Q by R square, potential K Q by R. K Q by R. Potential due to single charge, potential due to isolated charge, or electric field due to isolated charge possible. Whether force or energy चाहिए तो two charges are separated by some distance. Right? Two charges are separated by some distance. Two charges are separated by some distance. Two charges are separated by some distance. Just a minute, students. Right? Now this one, how to find out? K Q into Q square by L. ये दोनों के बीच में क्या आता? प्लस K कैपिटल Q स्मॉल q अपॉन L. अगेन ये दोनों के बीच में K कैपिटल Q स्मॉल q अपॉन L is equal to 0. Sum of the all the potential energies system equilibrium means total potential energy of the system is equal to 0. Then what we can write? K Q square upon L is equal to minus 2 times of K Q upon K Q upon L. K get cancel, L get cancel, 1Q get cancel. Q is equal to minus 2Q. Then Q is equal to minus Q by 2. So minus Q by 2 you have option 3. Option 3 is the correct option. So minus Q by 2. Minus Q by 2. Option 3 is correct. So let us go for next question please. Consider a capacitor circuit charged by battery to a potential difference V0 as shown in the figure. As shown in the figure, when the dielectric slab is inserted in both the capacitor, the new potential difference will be. When dielectric slab is inserted, what is the new potential difference is asking. What is the new potential difference? First case में what is the effective capacitance? Both are parallel combination. So 4 C naught. Then what is the charge? First case, in this case, what is the effective capacitance here? What is the effective capacitance? C effective is equal to 4 C naught. Because of C parallel में क्या बोले formula में C1 plus C2 4 C naught. Then what is the charge on this one? The total charge is equal to C effective into applied potential is V naught 4 times of C naught V naught. 4 times of C naught V naught. So in the first case, whereas in the second case, what is the total charge will be remain same, but इधर क्या करे? So what is the effective capacitance? First time dielectric constant K place करे तो इसका capacitance K times of C naught, इसका capacitance plus K by 2 times of 3 C naught effective capacitance. So effective capacitance, the new potential difference is asking. So this is a new potential difference V dash or V is equal to 4 times of C naught V naught. CV is equal to 4 times of C naught V naught. So इसमें से क्या निकाल सकते? So क्या निकाल सकते? V into so 2 plus 3 5 K C naught upon 2 is equal to 4 times of C naught V naught. C naught get cancelled. C naught get cancelled. So what is remain? The new potential is 8 V naught upon 5K. 8 V naught upon 5K. Very simple. So इसका effective capacitance निकाले 4 C naught. The effective capacitance 4 C naught. So then what is the total charge of the system? 4 C naught V naught. So after placing dielectric also charge remains same. Charge not decreases. So charge Q is equal to 4 times of C naught V naught. इसका भी इसका Q is equal to C effective into new potential. C effective K times of C naught. So K by 2 times of 3 C naught. So दोनों ऐड करें, पैरेलल कॉम्बिनेशन दोनों ऐड करें, C1 प्लस C2 ऐड करें, उसमें निकाले तो सो इफेक्टिव पोटेंशियल आ गया. द न्यू पोटेंशियल 8 V naught by 5K. Let us go for next question please. So ये already explain किया. 10 microcoulomb is placed at 0,0. Another charge 5 microcoulomb placed at 0, 3 to 3. The work done by this already explained 0. Last session में है, please check करो. It is 0 you will get. Right? So thank you my dear students. So this is tomorrow we'll start in the next session. Electric current. So we'll start tomorrow. Thank you and thank you very much.